speedier than the surface of space-time can remain mindful of it. It'll just tear. I'm terrified by this. As of now, our night sky is changing rapidly, and in essentially an issue of numerous years, on the off chance that not sooner, it could become unrecognizable. Cosmologists in general are sounding the alarm. Experts like Neil deGrasse Tyson have actually confirmed the inevitable impact of Polaris, and the story behind it is extremely frightening. Polaris, known as the North Star, has for quite a while been a constant in our night sky, serving as a vital reference point for stargazers, guides, and cosmologists. However, this could soon change, transforming our night sky and altering cosmic assessments. Let's dive into the significance of this threat and its implications for all of us. Join us as we uncover the story of Polaris as it approaches its end. For a prolonged stretch of time, Polaris has guided mariners and stargazers alike, standing firm as a guiding light. Its unwavering presence in the night sky has been central for navigation. However, this stability may soon be disrupted. In September 2023, a research paper presented by the respected Royal Astronomical Society cast doubt on the future of this celestial illuminator. Polaris is near the very edge of exploding, potentially vanishing from the night sky forever. Before we explore the consequences of this revelation, let's understand more about Polaris. Also known as the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole. Positioned nearly straight above Earth's North Pole, it appears almost stationary in the northern sky. Located in the constellation Ursa Minor, or the Little Dipper, Polaris shines as a relatively bright yellow-white supergiant star, much larger and brighter than our Sun. It is not a solitary star but part of a complex triple star system, with Polaris A and Polaris B forming a binary pair while Polaris B orbits them. The interactions between these stars create gravitational forces that shape their orbits and influence their behavior. Any disturbances in these interactions can lead to unpredictable variations in the star's brightness or pulsation patterns. However, the specific mechanisms behind these interactions remain unclear. Polaris is situated approximately 323 light-years from Earth, meaning the light we see from it today began its journey centuries ago. Thus, if Polaris were to explode now, we wouldn't observe it until more than 3 centuries later. The fact that Polaris has lasted this long suggests it may already have exploded, and we are yet to witness the light from that event. Since ancient times, the North Star has held immense cultural, navigational, and symbolic significance. Its reliability and fixed position made it an essential guide for ancient sailors, helping them navigate seas and lands. Symbolically, Polaris represented stability and direction, remaining steadfast amidst the ever-changing night sky. For astronomers, Polaris served as a crucial reference point, aiding the study of celestial movements and variable stars. As a Cepheid variable star, its periodic variations in brightness have provided valuable insights into stellar properties and the nature of variable stars. This characteristic also played a key role in determining galactic distances and calibrating instruments. These pulsations follow a predictable pattern, which has long been standard for the star, making its behavior easy to anticipate. However, recently, Polaris has deviated from this typical behavior. This irregularity in its pulsation cycle has puzzled astronomers, prompting closer examination of this celestial anomaly. Instead of its usual predictable pattern, Polaris has begun exhibiting inconsistent periods of dimming and brightening. Experts are now raising concerns that the star may be nearing the end of its life. This aligns with behaviors typically observed in stars approaching the final stages of their life cycles. The ongoing extension of Polaris' pulsation period, which was once stable, can be attributed to interactions within its stellar system. A yearly increase in the pulsation period of 4 to 5 seconds, though seemingly minor, carries significant implications. Some space experts suggest that gravitational interactions among the Polaris stars may be causing these changes in its environment, directly affecting its pulsation patterns. However, others are more alarmed, believing that the star is on the brink of exploding. The similarities between Polaris behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have displayed unusual irregularities in their luminosity, raising concerns about potential explosions. Red supergiant stars in their twilight stages often exhibit such irregularities before reaching the pinnacle of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention has not yet been officially directed toward Polaris. As a red supergiant star approaches the end of its life cycle, it undergoes various stages including the main sequence, red giant phase, and finally a supernova explosion. Based on Polaris' unusual pulsations, researchers predict it has entered the helium-burning stages typical of stars nearing their end. These peculiarities in Polaris behavior align with patterns indicative of supergiant stars in their twilight stages. However, definitive signs of its imminent supernova remain uncertain. Astronomers are continuously analyzing these anomalies to understand Polaris' fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, possibly outshining the Moon and becoming one of the brightest objects visible for weeks or even months. Its appearance could temporarily alter the night sky, reshaping our perception of familiar celestial formations like the Big Dipper, of which Polaris is a part. Rest assured, Earth would likely remain completely safe even if Polaris were to explode, given its mass and distance from us. While a Polaris explosion might not be as visually striking as Betelgeuse's, it could still be visible to the naked eye. For a lengthy period and overshadowing close-by stars, cosmologists and observatories would without a doubt pay heed, igniting revenue inside the scholastic community and among stargazers worldwide. Anyway, the particular visibility and effect on Earth's current environment or climatic conditions would be less critical compared to a closer cosmic explosion event. But what about Polaris itself? What will its destiny be after a potential cosmic explosion event? We should clarify one thing. While giant stars commonly end their lives in a cosmic explosion blast, this is probably not the case with Polaris. When a huge star goes supernova, a gigantic blast occurs inside it, marking the final catastrophic stage in its life. This process involves a complete collapse of the core, triggering a tremendous shock wave that causes the star to detonate violently. However, Polaris isn't large enough to go through such a blast. Rather, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This change won't result in a cosmic explosion blast, but rather a quiet end as it progresses into a small, incredibly dense celestial remnant. A white dwarf is the remnant of a low or medium-mass star that has depleted its nuclear fuel. It is extremely dense, probably as massive as the Sun but packed into the size of Earth. When this happens, we will no longer see its remnants from our planet in the same way we observe the star today. Looking at the normal effects of a Polaris explosion in comparison with historical cosmic explosion events provides valuable insights into the development of stars and their ultimate fates. Comparing our expectations with actual observations, such as SN 1987A and later events like SN 2011 Fe or SN 2014 J, provides significant data for understanding the possible outcomes of Polaris destruction. SN 1354, for instance, resulted in the formation of the Crab Nebula, a cloud that continues to grow and emit radiation across various frequencies, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into nucleosynthesis processes and the properties of supernova remnants, such as nebula formation, the release of cosmic rays, and variations in brightness. These can offer insights into Polaris' unique characteristics. The formation of nebulae like the Crab Nebula results from the ejection of material during the supernova explosion, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the process of stellar birth and death. Furthermore, the release of cosmic rays, high-energy particles accelerated by the supernova shockwave, has implications for astrophysical processes and cosmic radiation conditions. To make a valid comparison, astronomers need to assess the mass, structure, and velocity of expelled material between Polaris' expected explosion and other observed events. This includes analyzing light curves, spectra, and remnants from these events, and extending similar features to Polaris' anticipated explosion, evaluating whether Polaris blast could lead to nebula formation or specific chemical dispersions. This enhances our understanding of its possible outcomes. Another crucial area of investigation involves assessing the pulsational variability of stars approaching their end stages, like Polaris, compared to observed supernova progenitors. This close assessment can help confirm similarities or deviations, providing insights into the explosion mechanism. Pulsational variability in stars nearing the end of their lives may indicate internal instability or imminent catastrophic events, offering clues to the evolutionary processes leading to supernova explosions. Despite careful observations and extensive research, astronomers remain puzzled by the anomalies observed in Polaris behavior. Unraveling the complex conditions driving these irregularities holds the key to advancing our understanding of stellar evolution. Understanding the forces behind Polaris' eccentric throbs requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a fundamental reference point in the night sky presents significant concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of cosmic assessments. The absence of Polaris could also impact navigation systems and cultural practices based on celestial landmarks, highlighting the importance of this celestial event. The peculiar behavior displayed by Polaris emphasizes the need for deeper investigations and dedicated research efforts. Astronomers must grapple with the complexities surrounding its erratic throbs and provide substantial answers. Recognizing the importance of advancing our understanding, we could ultimately unravel great complexities. Finally, the answer to Polaris' fate remains uncertain, and only time will reveal its true essence. Nonetheless, the pursuit of knowledge and understanding in the face of boundless uncertainty is a testament to humankind's enduring curiosity in unraveling the mysteries of the universe. As we ponder the fate of Polaris, it's essential to recognize its role as a celestial marker as well as a window into broader cosmic phenomena. The North Star has been pivotal in expanding our understanding of the night sky. Ancient cultures used its position to develop schedules and seasonal agricultural practices, linking celestial events to everyday activities. As civilizations advanced, Polaris' stable position provided navigational guides that facilitated exploration and trade, marking it as a cornerstone of ocean history. In modern cosmology, Polaris serves as an essential reference point for telescopes and observational instruments. Its steady brilliance has allowed astronomers to refine their measurements of the universe's scale. The star's predictable light output contributes to the cosmic distance ladder, a key tool for measuring distances to distant galaxies and understanding the expanding universe. Interestingly, the study of Polaris also opens avenues for exploring stellar evolution. By analyzing its life cycle, scientists gain insights into the broader life cycles of similar stars. The properties of periodic variables, including their pulsation periods and luminosity variations, allow researchers to make comparisons with other stars, enhancing our understanding of stellar characteristics across different stages of life. As we investigate the final stages of a star like Polaris, we must also consider the implications of its potential transformation into a white dwarf. This process is a fate shared by many stars in the universe, leading to the formation of celestial remnants that will endure for billions of years. The study of white dwarfs has significant implications for our understanding of stellar and cosmic evolution. Moreover, the relationship between dying stars and their surroundings is a fascinating area of study. When stars shed their outer layers, they contribute to the interstellar medium, enriching it with heavier elements formed through nucleosynthesis during their lifetimes. This recycling process is crucial for the formation of new stars, planets, and ultimately life itself. By examining the remnants of stars like Polaris, scientists can trace the pathways of matter throughout the universe. The potential explosion of a star like Polaris raises questions about its impact on. Despite its scientific implications, the story of Polaris also raises philosophical considerations about humankind's place in the universe. As our understanding of large-scale life cycles grows, we are reminded of the transient nature of celestial bodies. Just as Polaris has guided humanity for millennia, its inevitable transformation will mark a change in our night sky, serving as a poignant reminder of the inevitable changes that pervade the universe. Astronomy has often inspired questions about the fate of our planet and species. As Polaris nears its potential end, it encourages us to reflect on our own existence and the legacy we leave behind. The search for knowledge about stars like Polaris cultivates a sense of wonder and curiosity that transcends generations. Ultimately, advancements in observation and breakthroughs in technology will allow astronomers to monitor Polaris more closely than ever before. Upcoming telescopes and space missions are designed to capture remarkable detail in celestial behavior. These observations will not only shed light on the life and death of Polaris but also enhance our understanding of the universe as a whole. The story of Polaris extends far beyond its visible presence in our night sky. It embodies centuries of human exploration, serves as a critical benchmark for cosmic measurements, and invites us to contemplate the deeper questions of existence. As we watch the fate of this beloved star unfold, we partake in a larger narrative about the universe, a narrative that continually shapes our understanding of life, time, and the cosmos.